All right, part 3. Well, let's see. This is pretty straightforward, right? Um, gives you it actually gives you a fairly accurate pH at a midpoint, so that's going to be our pKa, and that's going to be just figuring out how many moles of the stuff that you had due to how much titrant you took. So we'll leave that one. Okay, this one was a fun one, probably. Titration of phosphoric acid. And you have to locate all these crazy X marks. So the first question was pK1. You can see the 3, 1, 2, 3 regions of titration. Over here on this side is where you are starting with H3PO4. When you've added one equivalent of base, you've titrated all of the H3PO4 into the first conjugate base, this guy. So this is where you get to at one equivalent of base. That's this point here. When you're halfway there, that's there. And that midpoint is the midpoint in this titration over here. So that defines that first pK. So pK1 or pKa1 is that guy. As you add the second, as you go from adding 1, that's your first endpoint. Now essentially you're doing another titration. As you start to add now a second, when you get to here, a second equivalent of your base, you've now gone from H2PO4 minus to HPO4 minus 2. And you look at that, and you have added exactly 2 equivalents. Along the way, you will have gone through a 50-50 point, so at 1.5 equivalents, you will be right there. Okay, now here was the one that I think that some people I think struggle with a little bit. If you have 3 times as much of one as the other, that is, if 3 times this one equals concentration of that one. This puts me in between, somewhere in between here and here. So I would know that I must be somewhere in this first titration region down here. Really the trick is, I mean, if you're given 3 times one thing, if you have 3x equals y, you've got less x, right? I mean, x could be 100, and y would therefore be 300. Okay, it's just easy to see that the other way around. So the point is, in between in this example, if my information is 3 times H3PO4 equals H2PO4 minus, first remember that this is the one I have more of, and 3 to 1 means 25% and 75%. Okay, it's not 1/3, 2/3, it's 1/4, 3/4. Because 3 times 1/4 is 3/4. So I need to be on the curve where I'm 25% H3 PO4. So I don't know why it's telling me that that would be the wrong answer, because that would in fact be the right answer. I'd have to be beyond halfway. I'm not 50-50 anymore. I'm 3/4 of the way toward the H2PO4. Oh, that's showing me the correct answer. That's what it has to be. And this one, which I think was the last one. Here you have a dipeptide. This part is the aspartate, and this part is the phenylalanine, and they are joined with a peptide bond or an amide bond. Aspartate itself is something that is really a triprotic acid. In other words, this proton, one of these three protons can be removed, this proton can be removed, and this proton can be removed. That's why it gives you three pKa's. There's the amino terminus, as we call it. That pKa is 10. This pKa that's the side chain, so that is 3.9. This pKa would be 2, but it's not actually there anymore because that is now connected to the N of the phenylalanine. So that gets us our next amino acid down there. So if we look at the given pKa's for phenylalanine, the pKa for the carboxyl terminus, that's the 1.8. And what would be the pKa of the amino terminus over here would be 9, but again, it's not there anymore because this bond means that this is not free to react anymore, and neither is this. Okay, so with the asp phi, in fact, let me call it by its one-letter abbreviation, DF. D for aspartic acid, F for phenylalanine. With asp phi, that is a triprotic weak acid. It has pKa at 1.8, approximately 2, pKa at 3.9, approximately 4, and pKa at 10. So as it titrates, it's going to go from the fully protonated form, that's what we got here, with the 1, 2, 3 acidic or labile protons. First one to come off will be the one with the lowest pKa, so that's that one. As we go through this first midpoint, we will be 50% this and 50% this minus that proton. So you can see the different forms of it. The fully protonated version, that's this guy, that's A. We'll call that H3 B. How about? That was letter A. And then there is the singly deprotonated, the first this you call this the triprotic, that's the diprotic. And that one is, oops, it's not, yeah, that would be B, because here you've taken off that first proton. The now monoprotic, after you've taken 2 protons off, that one is going to be D over here. Notice this proton is still here, that's the last one to go. And then the fully deprotonated will be C. Okay, so you just have to place yourself on the curve at B is going to be where you're basically 50-50. A and B. C is going to be where you're almost entirely B over here. D is going to be 50-50 between form B and form C. C is going to be when you're 50-50 between form B and form D. Point D is going to be you're entirely at figure D. F is going to be halfway in between D and C. And G is going to be the last endpoint, where you're at 100% C. Alright, and I think that is it for that assignment. Hope that helped.